Recently, we were shocked by the news regarding the death of two of our UITM students from Semenanjung due to exhaustion and excessive stress. So my team members and I would like to take this opportunity to remind everyone to prioritize your health and make sure that you can manage your time in between studying and resting, because it is okay to take a break when you are tired. We would also like to remind everyone, including the lecturers and students, to stay safe and stay healthy, especially during this pandemic. So without further ado, let's jump straight into the presentation. A very good morning and greetings to everyone, especially to the respectful Coordinator of Faculty Computer and Mathematical Science, Dr. Khairul Anwar, Honorable Judges Encik Saiful Nizam and Puan Adalina Ibund, our lovely lecturer in charge for STA108 Group 2, Madam Hazina Hanafia, and to all of our fellow friends. We are Part 4 students from the Faculty of Applied Science, AS120, have been assigned to conduct a group project under the course of Statistics and Probability STA108. The title of our group project is The Effect on Precipitation on Agricultural Production. Before proceeding, I would like to introduce myself and the other of my team members. Our group consists of 4 members, which is led by Ozari Dainis Ejim. The rest of the members include Noreen Fazlin, Zohara Nadia, and me myself, Eva Estevia Moses.
So, precipitation is any form of water or moisture that falls onto the surface of the earth from any form of clouds, and they may come in various forms such as snow, hail, sleet. However, a major of them actually falls in the form of rainfall. And production in this context is defined as the amount of agricultural production or yield in the form of units per month. So the yield from agricultural production is dependent on the amount of water it receives in rainfall. So rainfall will undoubtedly pose an impact on the agricultural yield. So in this study, the amount of rainfall in millimeters and the production in units is taken as two variables, with the former being the dependent variable and the latter being the independent variable to better understand the relationship between the two. So the problem statement is, what is the effect of variability in rainfall on the total agricultural production per month, and how does that amount of production is affected by the amount of rainfall?
Assalamualaikum and hi, my name is Noreen Fazlin, and the objective in this study is to obtain the numerical information on the study of agricultural production from precipitation and to determine the relationship between variability of rainfall and agricultural production.
Assalamualaikum and greetings. My name is Zohara Nadia and I will be explaining on the significance of this study. Normal rainfall is essential for adequate agricultural output. Hence, it is important to know the effect of rainfall on agricultural production. This study is carried out in order to establish an effective method to bring the maximum amount of production to be collected. For example, growth from seed, soil health, and disease and mold are the factors which affect the precipitation. So, by conducting this study, we can improve the method used in crop production in order to achieve the best result for it. Statistical analysis means investigating trends, patterns, and relationships using quantitative data. This study used descriptive statistical analysis, which enables us to represent and interpret data more efficiently through numerical calculation, graph, or table. It involves various processes such as measure of central tendency, which is mean, and a measure of dispersion, which is standard deviation. Thus, I will elaborate more on these two numerical techniques. The mean is the average or the most common value in a collection of numbers. You will notice, however, that the mean is not often one of the actual values that you have observed in your dataset. In this context, the average rainfall received and the average agricultural production. One of its important properties is that it minimizes error in the prediction of any value in the dataset. That is, it is the value that produces the lowest amount of error from all other values in the dataset. Next, it includes every value in your dataset as part of the calculation. In addition, the mean is the only measure of central tendency, where the sum of the deviations of each value from the mean is always zero. A standard deviation is a measure of how dispersed data is in relation to the mean. Low standard deviation means data are clustered around the mean, and high standard deviation indicates that the data are more spread out. A standard deviation close to zero indicates that the data points are close to the mean, whereas a high or low standard deviation indicates that the data points are respectively above or below the mean. In this context, it enables us to monitor the consistency of production based on the amount of rainfall received.
So we move on to relationship analysis. The first subtopic is scatter diagram. What is scatter diagram? The scatter diagram is a graphical technique used in this study. The scatter diagram is a tool for determining how closely two variables, agricultural production and rainfall, are related by analyzing their relationship. We predicted that the graph will have decreasing trends. This means that the decreasing amount of rainfall, the decreasing agricultural production per month. There will be also a moderate effect of rainfall on agricultural productions. This is because there is an ideal amount of rainfall in any given growing seasons for most crops. If the average rainfall is much lower or higher than the ideal, it can lead to significant problems, from droughts, crops to lower yield. Too much watering could drown the crops, especially if there has been rainfall for several days. However, a combination of not enough watering and no rainfall could also lead to drying crops, which definitely will decrease the agricultural production. The second subtopic is correlation analysis. The correlation coefficient is a statistical measure of the strength of the relationship between the relative movement of two variables. The agricultural productions as the independent variable is labeled as X, while the rainfall as the dependent variable is labeled as Y. As you can see in equation 3, which was the peasant's product movement, the correlation coefficient formula has been used to calculate the strength of relationship between variable rainfall and agricultural production. As you can see in table 2.2.2.1, illustrate the range of the coefficients and the corresponding strength of each range. The value range is between -1 and 1. A calculated number greater than 1 or less than -1 means that there was an error in the correlation measurement. A correlation of -1 shows a perfect negative correlation, while a correlation of 1 shows a perfect positive correlation. Meanwhile, the correlation of 0.0 shows no linear relationship between the movement of two variables. When R, which was the value of correlation calculated, was obtained, R squared, the coefficient determinations, was calculated by squaring the R value obtained in equation 3. The coefficient of determinations R squared indicate the proportion of variance in a variable that is predicted from another variable.
2.3 Regression analysis. Regression analysis is a statistical method that is done for two purposes. Firstly is to model linear relationship between two variables, and secondly is to estimate the independent values. This analysis is very important as it allows us to predict the outcome with a relatively small amount of error. Equation 4 is the equation for the regression line, and based from the equation, A is the y-intercept or the level of y when x is 0, while B refers to the slope of the regression line. Y and x, on the other hand, are both respectively termed as the dependent variable and independent variable. Moving on to the next diagram, which is the formula to the y-intercept and the slope. These formulas are very important as it is used to create the regression line. The first formula is used to create a straight line to show the relationship between the variables, while the second formula is used to find the slope of the regression line.
Based on table 3.1.1.1, the average rainfall is 176.4 mm. The rainfall dispersed by 94.15 mm from its mean. For the production, the average production is 273,375.2 units. The production is dispersed by 84,311.26 units from its mean. Based on the results, it can be said that the effect of precipitation, which is rainfall, affect greatly on the agricultural production. The high value of standard deviation indicates that the data points are above the mean as shown in the figure 3.1.1.1.
So for my next part, I will be explaining more on the result and discussion on the correlation between rainfall and the agricultural production. So the correlation coefficient obtained between the two variables of the monthly precipitation in the form of rainfall and the agricultural production is valued at negative 0.617. Hence, the relationship between the amount of precipitation in the agricultural production can be interpreted as a moderate negative relationship. When referring back to the correlation coefficient strength table, when a value falls within negative 0.5 and negative 0.7, that relationship between the two variables can be classified as a moderate relationship. The moderate correlation explains that there is a connection between the two variables and they are related. However, they are not as strong as a strong relation. This means that the rainfall does have an effect on the agricultural production, however, it does not strongly affect said production, meaning the rainfall may be one of the causes in the decrement of production, but it is not the dominant cause for any reduced production. Furthermore, the negative correlation means that the rainfall and the agricultural production is actually inversely proportional to each other, which means as the amount of rainfall increases in millimeters, the amount of production will decrease in units, or vice versa. As the amount of production increase in units, the amount of rainfall will decrease in millimeters. So for the coefficient of determination, according to table 3.2.1.1, the coefficient of determination we provided is valued at 38.1%. This means between the rainfall and agricultural production, the variation in agricultural production can be explained by the amount of rainfall by 38.1%. Further explanation means that the amount of production or the variability of production is manipulated by 38.1% by the amount of rainfall received. This means that with this value, it signifies a moderate relation, and it can be used as a somewhat reliable model for future prediction in the amount of production and further improvements.
3.3 Regression Analysis. So I will be elaborating more about the linear model. The table 3.3.11 refers to the linear regression analysis summary for rainfall predicting production. And from the table, the coefficient for rainfall, which is 551.159, is the slope of the regression line, while the value 370600 is the y-intercept of the regression line. From this data, the graph equation of the estimated regression line is y equal 370600 negative signs 551.16x. Looking at the values, we can see that there's a negative linear relationship between the agricultural production and the amount of rainfall received. These values indicates that for every 1 unit increase in the amount of rainfall, the average yield from agricultural production will decrease by 551.159 in millimeters. Furthermore, there is a small value of standard error under the intercept, which is 249.54. This value gives us an indication that our mean is relatively close to the true mean of our overall population. The p-value of this regression line, which is 0.06, shows that the variable is not statistically significant as the value is larger than the significant value, which is 0.05. In other words, there is insufficient evidence in the sample to conclude that a non-zero correlation exists in these variables.
As you can see on the graph in figure 3.3.2, the agricultural production is plotted on the vertical axis and rainfall is on horizontal axis. There are decreasing trends between rainfall and agricultural production. This means that as the amount of rainfall decreases, the agricultural production per month will also decrease. This can be concluded that there are moderate effects of rainfall on agricultural production per month.
So the reason why the amount of production decreases as the amount of rainfall increases is due to a process called denitrification. So denitrification process is the process where the nitrates or solution slowly eluded away due to amount of excessive rainfall or excessive amount of water content in the soil. Furthermore, the oversaturation will also lead to the softer soil, means plants that require a stable base for their roots can't grow properly, and the increasing amount of water content will also create a habitable environment for denitrifying bacteria, fungus, and disease spreading bacteria and fungus. So denitrifying bacteria are bacteria that help in the process of denitrification, where they convert nitrates found in the soil into gaseous nitrogen. So as a conclusion, in this study it has been discovered that the relationship between the rainfall and agricultural production possesses a correlation coefficient of negative 0.617 and a coefficient of determination of 38.1%. The former value signifies that they possess a moderate negative relationship with each other, and the latter value explains that the amount of production is manipulated by 38.1% by the amount of rainfall received. Finally, a scatter diagram illustrates the visual representation of the moderate negative relationship between the rainfall and agricultural production, and the scatter diagram further proves the accuracy of the correlation coefficient. And finally, the regression line or the best fit line equation is also obtained as y equals to negative 551.16x plus 370,600. So this equation describes the response in the amount of production depending on the amount of rainfall or variable x received. So using this equation, we can determine the amount of production that we will be receiving depending on the amount of x that is recorded in that month. Hence, it can be concluded that the yield from agricultural production is dependent on the amount of water supplied to the fields. In theory, high amounts of water should be beneficial to the crop production. However, in this case of oversaturation towards the crops, it may lead to a reduced production. Hence, in the relationship that rainfall and crop production we obtain in this study is that they possess a relationship that is inversely proportional to each other.
Next is rain usually thought as a boon to crops and field, but most crops have an ideal amount of rainfall during any given growing season. If the average rainfall is significantly less or more than the ideal, it can cause serious problems such as drought crops and lower yield. Too much watering, especially if there has been rain, could drown the crops. While a combination of insufficient watering and lack of rainfall could cause crop to perish, crop death, or lower yield. Overwatering, on the other hand, can result in brown crop leaf tips as well as root rot and other problems. If crops become too saturated or drenched, they are susceptible to mold or become infected with fungus. The soil can also begin to accumulate bacteria, mold, and fungus, which depletes the nutrients such as nitrates that is beneficial to plant growth. The problem of excessive rainfall is sometimes unavoidable as the duration, severity, and when it rains, it are out of control. However, the amount of water received can be reduced so that the production is not heavily affected. Firstly, a better irrigation system can be implemented so that the accumulation of water in the field can be quickly flowed out. A greenhouse can also be used, especially for sensitive plants, so that the crop production can be maintained at a desirable rate. To conclude, an ideal balance of water and a proper irrigation system is fundamental for a favorable. That's all from our group. Thank you for listening and stay safe.